All right, you guys, how's everybody? We got a lesson today, okay? We're going to talk about approximating rates of change using a tangent line. All right, so let's read what this says. In many instances, finding the value of a function is possible, but we use calculus to approximate it by finding a y value on the tangent. So, like, let's say I've got a tangent line right here, and I'm trying to find, like, the actual point on the circle right here. But what I could do is I could find the value of the point on the tangent line and say, that's pretty close. Okay, it's called local linearization. It's kind of weird, but let's check this out, all right? If 2, -2 is a point on the graph of x squared plus y squared plus 2y equals 4, use the equation of a tangent line passing through that point to approximate a y. All right, look, all I see right here, equation of a tangent line, okay? Remember, every time we I minus mx minus x1, and this giving me is y. Okay, so I've already got x1, y1. The only thing I need right now is m. Okay, and you guys remember that m, slope, and slope means derivative. Now this, we're going to have to take the derivative implicit. There we go. And the derivative of this is 2x. Derivative of y squared is 2y dy dx. The derivative of 2y is 2 dy dx, and the derivative of 4 is 0. You can either plug the points in right now, or you can solve for dy dx. I'm going to go ahead and subtract that to the other side. Okay, so I get negative 2x. I'm going to go ahead and factor out a dy dx right here. And so I end up getting dy dx is negative 2x over 2y plus 2. I could reduce that by 2's if I wanted to, but I don't really need to. And now I'm plugging in 2 for x and negative 2 for y. So that gives me negative 4 over negative 4 plus 2 is negative 2, okay, which will give me 2. Here's the equation of y minus negative equals mx minus, okay, that's the equation of my tangent line. So now that I have that, to say, okay, for when the x-coordinate is 2.1, right, on here, because again, I can't really like just plug it in and solve it. It's not going to work very well. So what I do is I just plug it into here. So I go, okay, y plus 2 is 2 times, now 2.1 minus 2 is 0.1, right? 2 times 0.1 is 0.2, and so when I subtract that over, I get 1.8. So that's approximately where the point is going to be because it's a linear approximation. I already made the equation of the tangent line, so here I just have to change it to where the x-coordinate is 1.9. So then this is 1.9 minus 2. 1.9 minus 2 is negative 0.1. So that's negative 0.2. And when I subtract 2 over, I get negative 2.2. Okay, so again, equation of tangent line, plug in the x. It's really, really not too bad. All right. Okay, now let's look at number 2. This gives me like no information really. It just gives me some points and stuff. But as soon as I see local linearization, I'm going to remember that means equation of the tangent line. And I know that for equation of the tangent line, I write y minus y1 equals x. Now let's kind of take pieces that are happening here, okay? x1, y1. So this is on the graph of f. Basically, on the graph of f, it's saying that the point 2, 3 is on there. Okay, now this is on the graph of f prime. So this is saying, shoot. Okay, so sorry about that. This is saying on the graph of f prime, when I plug in 2, I get negative 2. All right, well, look, guys, This is x1 and y1. This is the slope at 2. That's actually m right there. So when I go to write my equation, it's like y minus 3 equals negative 2, because that was the derivative at that x minus 2. Okay? Now, if I'm trying to approximate 0.01, 2.01 minus 2, that's 0.01. Negative 2 times 0.01 is negative 0.02. And when I add the 3 over, I guess I get 2.98. So that's my linear approximation. Okay, just tangent line and then plugging in a point. Okay, here's one more little part of this section. Okay, graph at the right models the rainfall in inches per hour from midnight. So we're going to say this is midnight until 6 a.m. during a rainstorm. Write a complete sentence to explain what A on the graph represents. Okay. So the first thing is time after midnight. At 3 hours after midnight, or I could just start at 10. And I'm going to look over here, the rate of rainfall is, look at the y coordinate, 1.0 what? Inches per hour. Okay? 3 a.m., the rate of rainfall is 1 hour. This says, what's the slope between A and B? That's 0. Write a complete sentence explaining. Okay. So what this is saying is the rate of rainfall is constant between A and B, which is like 3 a.m. and 4 a.m. Right? The rate is constant. Okay, what is the slope of the graph? And well, this goes down. Now be careful, don't count the squares. And it goes down 5 squares, but it's really only going down 5 over 1. So it's negative 1. And then you guys, okay, it's inches per hour. That's this over hours. So it's actually inches per hour squared, right? Which is a rate of a rate. It's a little bit difficult to write, but here's how I would write it. From 4 a.m. to 5 a.m., the rate of change of the rate of rainfall is decreasing, because it was negative. The rate of change of the rate of the rainfall is decreasing by 1 inch per hour squared. So it's like a rate of a rate. Okay? All right. So hopefully that all makes sense to practice these tangent line approximations. Okay? Linear approximations, and then just kind of practice through a few of these questions. I'm going to give you guys the answers to all of these. These are some very page right here, 16 through 27. I just want you to spend the time in class. I want you to do. All right, so especially okay, and I will have a 2 video for you guys. All right, cool. I will send the answers to this on. Thanks, guys.